Alright, I just wanted to make a video on practical approach to silent, dust-free computing with excellent thermals. I've had this computer on the right for close to 10 years, and I'll show you it's effectively dust-free inside, and I haven't cleaned it once, and I've never had problems with temperatures. I wanted to set it and forget it, silent build with no dust. Those are my requirements. I want it to be quiet, I want the thermals to be adequate, and I want there to be no dust. And I wanted low maintenance. And so I believe I achieved that, after years of computing. I'll show you how I did it. And this is a ThinkServer TS140 that I think I bought back in 2015. And there's all the dust I've accumulated over 8 to 10 years. That motherboard looks pretty much brand new. Yep, I haven't cleaned it for 8 or 10 years. There's dust. There's evidence of actually used it. And there's some more on the fan. But I've never cleaned that. And you can see how much is accumulated. I swipe my finger there down to see how much dust is accumulated. I'll show you on the outside where there were no air filters. I'll show you the secret sauce of getting this done. And so this is a computer I've been most happy with out of all my builds. Is this ThinkServer. Everything's silent. It's got these rubber grommets, and it was it's not that I was against building at the time, or I didn't trust myself to build one. In fact, I just built this new one on the left, which I'll go over. But it was because it was the best price. I did upgrade the thermal from the stock heatsink to this thermal tower way back when. This is the stock fan. I didn't want to buy a new fan, so I just used the stock CPU fan. It's a 4-pin connector. It continued to, and it spun up a lot less once I changed out this. And the thermal paste I use here is Artic Silver 3 that I had back in the day, but it's not stock thermal paste. I also, on this chipset, I took it off back then and changed the thermal paste out to Artic Silver as well. Here's more example of how little dust there was. This is on the intake fan, and all the dust and stuff you see down there is something I improved on my new case, and I'll show you why that happened. That's because some of the air filter came undone on the edge. And so here, I'll move over to the front. There's where we can see there. It looks like a total mess, but this is what the secret sauce is. This is just a standard household air filter for your HVAC unit. And then I taped up any area air could sneak through. Anything that there's potential for airflow to come through, I think. And here's an example of how much dust there probably should have been. So this is outside the case, outside the location that has the air filter, and that's all dust. And I had the drive bays that I switched over to my new build. And around the drive bays, on all the edges, I placed the air tape as well. Now, if you look, this is something I improved on the new build. Is you see this came undone. I don't know when, but that's probably why I got that dust in there. If it had it not, I don't think I would have. And here's the air filter. This is just a standard household air filter. That's something else I improved on the new design. I didn't go with ones with this metal reinforcement. I'll show you the new one. That's a pain to cut. It's possible to ruin your scissors, or you have to use wire snips. It's just a total pain to cut with when you're cutting all the air filter to size. Now I'm going to move this over so I can show you my new build and things I've improved. And again, this is after 8 years. It was successful, and I just wanted, a practical approach. As you can see, this is a Thermaltake V100 case. It's pretty much the case I could find with the most amount of ventilation and space for the lowest price. And I like it. It's super light. I have no negative comments about it. Here's what I improved. I used 3M Scotch's 3M heavy duty packing tape. And use this tape instead of the masking tape, because the masking tape will come off over time. It's not as sticky, and this stuff is nice because it doesn't leave a sticky residue when you tape it down. So we can remove it, and even over time the adhesive properties don't deteriorate, and it stays great. And now here's the air filter. I left these pleats. That's another thing I improved. I left the pleats for increased surface area to decrease the amount of resistance to airflow. And instead of using the one with the wire reinforcement, I found one. This was a 20-inch by 25-inch $7 air filter that I cut out, and so this reinforcement is now with this plastic thing that's melted to each pleat. And here, I'll get you a better video of it right here. And this is a 140 millimeter location that this one's on. And this build, I'll just go over the components so you get an idea of how much heat I'm generating. This is a 12700K, Intel 12700K. This is a 1050 Ti, and this came out of my old build. And I did not clean it before I put it in here. And I'm going to show you how much dust is on there. Pretty much none. So over time, the important thing to understand is over time, dust is not going to clog up anything. And so initially you might have restrict airflow as in comparison to not having any air filters. But over time, it's going to be you're going to have very predictable heat dissipation, because you're not going to jam up or clog anything up with dust and restrict airflow or rob thermal efficiency. And this is a, as I mentioned, a 12700K Intel 1050 Ti. The motherboard's a MSI Z690 Pro, and this is a Thermalright Peerless Assassin SE thermal tower, and these are Artic Cooling P12 fans, and then for my power supply I used a Seasonic Gold 850 watt. And so expanding more on how I did this, so this one I actually used, this is the one I first installed, and I used the wire mesh one. I just got so fed up with cutting it, I finished this one, and then I used the other plastic reinforced air filters for the rest of the build. And as you notice, I taped up here, so anywhere the air could sneak past, I taped off. And then, so your question may be, before we move on to the thermals, on this one I used the TF7 Thermalright TF7 thermal paste between the GPU as well as the cooler. I use a Artic MX4, and here I use Artic MX4. I just decided to use whatever this came with to try it out. And so I do replace all of the thermal paste, and I think that helps as well. I believe it or not, I replace it. I've had such good results. I do it in my laptops. I have such good results. I don't even, when I first buy the thing, I don't even check the stock thermals. I just replace it right before I even install the components. Which I probably shouldn't do, but I haven't had a problem with it. I should probably test them first. So that's what I'm using for thermal paste. I mentioned I kept the increased surface area. Now the question is, you may be wondering, how are my thermals, considering I've restricted all this airflow, and I only have one exhaust fan, and with ambient temperatures of 75 degrees Fahrenheit, I get the CPU idles at 45 degrees Celsius, and that's with me being unable to hear anything, even tell that the computer's on. Nothing spinning. Like I hear no noise, and these fans are all set to the same fan curve, and they're spinning at about 400 to 500 RPM, and I can't hear them. These Artic Cooling P12s had, some critique about whine from the motor around certain RPMs or while it was ramping up. I tested all these. I listened to them very carefully while asking the motherboard to spin the fans up. I didn't experience any of that. Although I did buy a pack of 5, and two of the five, one made a clicking sound every time it would spin, with every revolution. So I scrapped that one. And the second one of them, it was just so off balance, it was vibrating. And these were pretty much flawless. There's no additional sound at any RPM. They weren't very well balanced, and so these are effectively silent. Under load, the thermals I'm achieving are with 75 degree Fahrenheit ambient temperature. This stays around, the CPU stays around 77 degrees Celsius, 78 degrees Celsius, and the max I'll get is 80 degrees Celsius, and that's under full load, sustained with the case closed. And these are spinning at they're not even at full speed. They're spinning at about, they're all set to the same curve, so they're all running at around 1200 to 1600 RPM. And I can hear them, but they're still pretty silent. The chipset at idle runs around 53 degrees Celsius, and it's actually the same, 55 degrees Celsius under full load. GPU, I haven't quite tested the thermals yet, but under idle conditions, those fans don't spin, so that's great. Now, regarding the power supply, that's the intake for the power supply. It under full load, the power supply will spin every 5 minutes for 15 seconds. This is a Seasonic Gold 850 watt power supply, so I'm getting excellent results there. So people may think I'm really restricting the airflow, but it's not. It's not to a degree that's impacting my ability to cool necessary components. And I'm then getting no thermal throttling. And I don't know if I showed you, I sealed up anywhere air could sneak through, it needs to be taped and sealed. And so I hope this is helpful for anyone that wants a practical approach to long-term, silent, dust-free computing. This is that. One other thing I want to mention is if you have heavier duty components, like you have a larger graphics card, this is a very efficient and small graphics card. If you have a heavy duty graphics card, you're probably going to need to add a couple case fans. I would add case fans before removing all the air filters. And this case did come with some mesh air filters that were total joke. I removed all those and I just replaced it with this. It doesn't look that great, but again, I didn't design this to look that great. I designed it in a way to be cool, headache-free, cool, adequate thermals, silent build. And that way, once it's built, I can set it and forget it and get hopefully up close to 10 years of dust-free, silent computing that I don't have to go in, clean out right now, and also not taking a hit on any thermal efficiency or thermal performance by dust entering the case and really getting into the components that are critical for cooling. And so dust on the air filter, not a big deal. And even if they do get dusty, I can always just remove it, cut a new one up, and put it back in. This one will be a little bit challenging because I've obviously put all this in before the components were installed. This one will be easy because the front panel can pop off, but you know, it's all passively cooled. I mean, it's all passive. Other than the exhaust fan, this is all going to be passive airflow. So hopefully there's enough surface area that I don't end up with that much dust over the course of, hopefully 10 years. Because again, this one's 8 years old, much smaller surface area, and I never changed it. It's still adequate amount of airflow, and it's a lot dirtier than the other one, but you can see that I never had to replace it. So this isn't an HVAC unit cooling the house, it's just a computer. So I'm hoping these air filters last that long. All right, hopefully this helps somebody trying to have a practical approach to long-term efficient cooling. Take care.